In the grand scheme of the universe, a human life is shorter than a lightning flash. We are born, we learn, we love, and then, just when we finally figure out how the world works, our bodies fail us. We disintegrate. We vanish. It is the ultimate paradox of our existence. If your car breaks down, you replace the part. If your roof leaks, you patch the hole. We are masters of maintenance. We can keep a classic car running for 100 years. We can keep a building standing for 1,000. But when it comes to us, to the biological machine we live in, we are helpless. No matter how much kale you eat, no matter how much you jog, and no matter how much money you have, there is a self-destruct sequence written into your code. For most of history, we accepted this as fate. But scientists are starting to ask a different question. Is death a law of physics, or is it just a technical problem, a bug in the code that we haven't figured out how to patch yet? Why do we age? Why can't we stop it? And most importantly, are we the last generation to die? To understand why we die, you have to understand how we are built. Your body is a factory. Every day, millions of your cells die, and your body prints new ones to replace them. It is a constant process of copying. But biology has a flaw. It's like making a photocopy of a photocopy. Over time, the image degrades. Errors creep in. The crisp lines of your youth turn into the blurry, gray static of old age. This isn't an accident. It's a mechanism called the Hayflick Limit. Inside your cells, your DNA is wrapped up in chromosomes, and at the tips of those chromosomes are little protective caps called telomeres. Think of them like the plastic tips on the ends of your shoelaces. They keep the DNA from fraying. But here is the catch. Every time your cells divide to make a new you, a tiny piece of that telomere gets chopped off. It's a countdown clock. Tick, tick, tick. When the telomeres run out, the cell stops dividing. It enters a state called senescence. It becomes a zombie cell. These zombie cells don't die. They just sit there, spewing out toxic chemicals that inflame the cells around them. They are the biological equivalent of trash piling up in the streets because the garbage trucks stopped running. This accumulation of cellular trash is what we call aging. Your skin sags, your organs stiffen, and eventually, the system crashes. But wait, if aging is caused by damage over time, like a car rusting, then everything should age, right? Wrong. Meet Teratopsis dohrnii, the immortal jellyfish. This tiny creature has a superpower we can only dream of. When it gets old, injured, or even just stressed out, it hits a biological reset button. It reverts its cells back to their earliest stage and starts its life over. It is biologically immortal. It doesn't defy the laws of physics, it just ignores the laws of aging. Then there are Hydras, tiny freshwater animals that don't seem to age at all. Their risk of death is the same at 1,000 days old as it is at 1 day old. If you had the biology of a Hydra, you wouldn't die of old age. You'd only die if something killed you, like a car crash or a falling piano. So nature has the technology. The code for immortality exists. It's running on this planet right now. So why don't we have it? Why did evolution give the jellyfish a reset button, but gave us a self-destruct sequence? The brutal truth is, evolution doesn't care about you. It cares about your genes. Once you pass your genes to the next generation, you are biologically obsolete. In fact, you are in the way. Nature wants you to die so your children, who have slightly upgraded code, can take your resources. Death isn't a bug, it's a feature. It's how the species upgrades. But humans are famous for rebelling against nature. We invented fire to fight the cold. We invented planes to fight gravity. And now we are trying to invent a cure for death. We are entering the age of gerolytics, medicines designed to kill aging. One approach is senolytics, drugs that hunt down those toxic zombie cells and flush them out of your system. In lab mice, this has already worked. Old mice given these drugs grew their fur back, ran faster, and lived 30% longer. Another approach is gene editing. If telomeres are the problem, why not just lengthen them? There is an enzyme called telomerase that refills those protective caps. If we activate it, our cells could divide forever. We would be immortal. But here is the deadly fix. There is another name for cells that divide forever and never die. We call it cancer. This is the great biological trade-off. The mechanisms that stop cancer, like cells dying when they get too old, are the exact same mechanisms that cause aging. If you turn off aging, you might turn on cancer. We are walking a tightrope over a pit of spikes. If biology is too messy, too risky, and too cancer-prone, maybe we are trying to fix the wrong machine. Maybe the future of immortality isn't biological, it's digital. This is the concept of mind uploading. If we can map every neuron and synapse in your brain, all 100 trillion connections, and run that simulation on a computer, would it be you? But this leads to a terrifying question. If you copy your brain to a computer, and the biological you is still sitting in the chair, which one is you? If I shoot the biological you, did you transfer? Or did you just die while a digital ghost pretends to be you? Living forever might be possible, but it might require us to stop being human entirely. Let's assume we succeed. We cure aging, we fix the DNA trap, we live for 500, 1,000, or 10,000 years. What happens to society? Death is the great equalizer. It clears out the old to make room for the new. It ensures that tyrants eventually fall, that bad ideas die out, and that progress happens. If the generation that invented the steam engine was still in charge, would we have ever invented the internet? Or would they have blocked it to protect their investments? A world without death is a world without change. A stagnant, frozen world where the rich get richer forever and the young never get a turn at the wheel. And on a personal level, scarcity gives things value. Gold is valuable because it is rare. Life is valuable because it is short. If you had an infinite number of days, would you ever write that book? Would you ever ask that person out? Or would you just say, I'll do it next century? The urgency of death is what drives the beauty of life. We probably won't live forever. The universe itself will eventually die, and us with it. But we are approaching a moment where aging becomes a choice, not a curse, where we might live healthy, vibrant lives to 150 or 200. The goal isn't to be immortal. The goal is to die young, as late as possible. For now, check your telomeres, eat your vegetables, and appreciate the time you have. It's the only thing you can't buy more of. Yet. But living forever is useless if the planet kills us first. We are trying to play God with our bodies, but we already tried playing God with the sky, and it backfired. Click here to see why controlling the weather is a deadly fix.